Hello, everyone. My name is Whitney Stoll. I'm the DC Post president, and welcome to our summer special First Friday webinar. And joining us today and understanding how building assessment and high performance envelope construction can achieve optimal project outcomes. With a presenter, Bob Duke from Bear. Joined by me today is Jim D'Amelia, who is behind the scenes moderating our webinar today and will be monitoring the chat. We have nearly 100 registered participants from all over the world. So I know you're excited to be excited about this program as we are. And so please, in welcoming our guest presenter, Bob Duke. Bob's going to discuss why building envelope assessments are crucial for achieving energy efficiency and building sustainability. This program continues the SAME DC Post programs that are sharing best practices for aligning building design and construction with the new federal guidelines for high performance building, sustainability, and the Executive Order 14057 criteria. But first, I'd like to welcome you all to our First Friday webinar series, which is provided to you through SAME's commitment to offering the AEC community effective training, development, and networking programs. The DC Post is helping sustain the future of the profession with these monthly education focus sessions to deliver topical and relevant content to our industry. So thank you all for joining us here today. If you haven't already, please feel free to use the chat to introduce yourselves, share your LinkedIn profile, and any contact information throughout the presentation. Ask questions so we can address them during the Q&A portion at the end. Also, if you're using the WebEx, since we are using the WebEx platform, you can go up to File, go down to Save, and Save Chat for this to save any of the contacts in here. We are recording this session, and we will post the webinar on our YouTube channel later on this month and send you the slides as well as your PDA certificate as soon as the webinar ends. So thank you all for joining us here today, and so glad that we can offer you an hour of education and virtual networking regardless of where you're attending from. Let's start with a moment of silence to remember our active duty military, first responders, and all who need our care and thoughts throughout the world right now. Thank you. And if you will, please join me in the Pledge of Allegiance. So I pledge allegiance
to the flag of the United States of America
and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. We'd like to take a moment to thank our DC Post annual Platinum and First Friday sponsor, Fox Rothschild. We truly appreciate your support. We could not put on our events without you, and we're grateful for your outstanding sponsorship to make this program possible. Your support helps us meet our society goals, including providing excellent content for our members, industry government engagement, building resilient communities, connecting with our future leaders through our student and young member groups, enriching our STEM pipeline, and preparing our military and veterans for life after service. If you're not already a DC Post sponsor, we'd like to support our post with annual sponsorship. We'd love to add your name to the slide for future programs and events this year. Annual Platinum sponsors and First Friday sponsors help support this webinar with free registration for SAME members and full-time students. Please visit our website for more information about sponsorship levels and how you can get back to the SAME community with your DC Post sponsorship. Now it's time for the main program. Please note this program will provide you one professional development hour from the DC Post. Look for an email with the subject line document delivery from the DC Post and Eventbrite with a copy of the program slides, your PDH certificate, and a list of the opt-in attendees who pre-registered for this session. We are recording this webinar and we'll post the video on our website later on. So I'm not going to read through the learning objectives on the slide since most of you saw the same objectives when you registered. Instead, I'm going to introduce our featured speaker in just a moment. And while I do the introductions, if you have not done so already, please use the chat to introduce yourself, share some contact information, and where you're calling in from. This is your webinar series, by the way, so for you to help you learn about the special topic, as well as help you expand your business network throughout the program. Any comments or ask any questions for the presenters? If there's a particular slide you want to talk about, please share that information in the chat so Bob can address it later on. And now I'd like to introduce Bob Duke, who's co-principal at Bear. Bob Duke from Bear is a company specializing in building envelope assessment and repair. It's based in Charleston, South Carolina, with an office in Washington, D.C. He began with a residential SPF company, expanding into large-scale commercial and federal operations. Bob co-founded Bear with retired Coast Guard Captain Casey Baker, and has held leadership roles in the Spray Polyurethane Foam Alliance, and is also an ABAA certified and chairs the existing building committee with the ABAA. So Bob, welcome. Super happy you're here, and I'm turning the program over to you.
Wonderful. Whitney, thank you so much. I appreciate your time. And I would be remiss if I didn't thank everyone today, the attendees, knowing that it's a Friday in the summer and a Friday before a holiday week. That's the fact that you're here is both impressive and appreciated. So thank you. First of all, a little bit about Bear. As Whitney mentioned, we are a women-owned and service-disabled veteran-owned small business. Our product offerings cover the range from existing building assessment to repair to specialty material installer on new construction projects. Next slide. Our team has walked, assessed, and provided investment-grade audits on over 80 million square feet of conditioned space. Our team members have been active in contractors and installers in this business for nearly 20 years. We have both board and executive director experience with the Spray Polyurethane Foam Alliance and with the Air Barrier Association of America, otherwise known as ABA. Our work product does indeed reduce life cycle earned lead credits, and it optimizes the efficiency and durability. And notably for our audience today, we also help you meet your federal requirements. The agenda is broken down into areas highlighted today, and they'll include the fact that we truly do believe that resiliency starts at the envelope. We'll take a look at the new build environment and its trends and the materials serving those trends. We'll take a look at existing buildings and the process of both evaluating a current building envelope and who's notably using those services, the products those evaluation assessments produce, and how those products point to solutions. We will then address the issues found and pinpointing problems, listing potential savings, gauging the impact on total cost of operation, as well as the problems caused by air intrusion will all be looked at today. Finally, we'll highlight two specific building materials that are gaining prominence in the building marketplace, in the new building marketplace. Next slide, please, Whitney. In our learning objectives, we're going to hit on some of the touch points that connect our process of approaching building envelope efficiency and resiliency to demonstrate how we work the process for your benefit, or how the process, regardless of who's doing it, can be worked to your benefit. Today is about the building envelope, and from the approach to new buildings to the approach to existing buildings. It's about the process of investigating, reporting, and repairing to create better buildings. And again, finally, we'll look at two materials that are now serving primarily the new build market, but also help with retrofits. Next slide. So here we see a couple of examples from the sublime to modern day. In the upper left-hand corner, we have a thatched hut. That's an undated photo from Africa. The middle top is one of the first known timber structures on the Solomon Islands, and that's made out of bamboo. The upper right is a large stone wall, creating the envelope and a smaller stone wall within, and that's from Machu Picchu. The identical looking towers you see down on your left are all made entirely of clay, and they reside in Yemen. And then finally, we get a look at a modern day nightscape of New York City. And I would dare you to try to guess how much that's pulling on the grid just in that picture there. Next slide, please, Whitney. So yes, we truly believe that resiliency begins at the envelope. And the type of resiliency we're talking about is simple. Let's go through some quick definitions. Resiliency, first of all, is the capacity to withstand or recover from difficulties, also known as toughness. Energy resilience is the ability to operate building energy services, such as heating, cooling, ventilation, plug loads, etc., during and in response to major disruption. The two central functions are passive survivability and grid resilience. And passive survivability is the ability to maintain safe indoor conditions in the event of an extended energy outage. So knowing that we as a company are headquartered in Charleston, South Carolina, that is an active hurricane area. So if anyone listening today has had the misfortune to be either in the path or directly affected by a major hurricane, you know that it can take days, sometimes weeks, for power and to be restored. And that puts a real premium on passive survivability. Next slide, please, Whitney. In terms of the building envelope itself, we see that the building envelope acts as a thermal barrier, helping to create a comfortable indoor environment. That exterior walls are the major component of any building envelope, and that sadly, it's through these same walls that we lose about 1.5 quads of energy through walls in commercial buildings only in America alone. So for those of you keeping score at home, 1.5 quads is 1.5 quadrillion BTUs of energy that is lost through walls. Next slide, please, Whitney. So where does that bring us? Let's take a look at the building envelope. Let's take a look at the areas that should be considered in both design and construction. We start at the roof, although notably many times the roof is handled as a separate entity. There's usually a separate roof plan and materials. So there's a whole market that serves the roof. So we're not going to dive into that today, but where the real envelope work starts is at the roof wall intersection. Then we move down into the walls. What type of thermal walls do you have, and are they durable, and are they built to last? What about the doors? Are you putting in high quality doors that are energy efficient and serve to help the envelope? Fenestrations. A fenestration is nothing more than a planned hole in your envelope. And are they sealed properly, and are they designed properly? Are you employing energy savings performance panels, which is essentially a more durable boost to the thermal? What about the other smaller planned holes in your envelope? Exhaust fans, ducts, vents. Are they properly designed, and you're ensuring that they're properly installed? And finally, the windows. Are you using high efficiency, dual pane, low E, argon windows? And are you enveloping them into the envelope so that they work as a system? And finally, knowing that every envelope is truly 6 sides, top, bottom, and four walls, if you do have an exposed crawl space, is it insulated, and is it air sealed? Next slide, please, Whitney. We wanted to take a brief moment to touch on federal policy and influence in the area of energy efficiency generally and building envelopes specifically. Next slide. There have been 2 major drivers of both policy and initiative in the federal space, and they are the DOE, the Department of Energy, and the Government Services Administration of the GSA. The DOE notes that air barrier solutions like sealants, membranes, spray foams are key to addressing air leakage in commercial buildings, which can account for about 20% of the total energy used to heat and cool buildings. From their Center of Emerging Building Technologies, the GSA puts out the metric that buildings represent 39% of U.S. energy consumption and 38% of all CO2 emissions. Now, if you juxtapose those 2 metrics, if 40% of energy consumption is done through buildings and air leakage accounts for 20% of the total loss of energy used to heat and cool buildings, you see that there's a waste factor there of approximately 50%, which is, quite frankly, dramatically high. So next slide, please, Whitney. With the federal agencies and their focus on energy efficiency is done is to generate sincere interest in the building envelope. Noting that, what exactly are the 4 barriers in a building envelope? They are air, bulk water, which is rain, moisture vapor, which is nothing more than water carried through the air, with the air, and then thermal. So we'll come back to those later. Next slide, please, Whitney. So since I'm speaking today to a SAME-based audience, there's no need to try to take a quasi-deep dive here into federal policy, other than to highlight the fact that the Energy Infrastructure and Security Act of 2007 has finally been made official and been mandated as of April 24th of this year, with DOE's final clean energy rule for buildings. The mandate itself is centered around the reduction of fossil fuel use for both new and renovation construction. And knowing that you'll receive the slide deck from today, if you want to go back and take a look at some of those metrics, please feel free. Next slide, please, Whitney. But what we do want to do, knowing that this is a heavily federalized marketplace, what we did want to do is provide a simple graphic as to how we got here, right? So it started with the Environmental Protection Act of 2005 and the Energy Infrastructure and Security Act of 2007. Those were put into place and signed into law, but they really weren't adopted heavily. That information, though, led to the Executive Order 14057, which was issued in 2022. That then turned around and that influenced the Federal Building Performance Standard issued the same year, which then informed the Federal Building Sustainability Plan. And all of that culminated just a couple of months ago, April 24th of this year, with the DOE's final Clean Energy Building Rule. Next slide, please, Whitney. So what do we know so far? We know that the building envelope is focused on exterior walls. There are 4 barriers to an effective building envelope: air, bulk water, moisture vapor, and thermal. We know that the federal agencies and federal marketplace are now actively pushing these efficiencies, and that culminated with the signing of the DOE Final Clean Energy Rule just a couple of months ago, April 24th. Again, those efficiencies and emission metrics, they're mandated. You can look at those in the slide. Next slide, please, Whitney. So let's take a look at new builds. Next slide. In the new build environment, there's been an increased emphasis on building envelope design and construction. There's a definitive trend towards something called continuous insulation, or CI, and those materials and systems are being pushed to the outermost portion of the envelope. Notably, the increase in emphasis in these new trends, there are new materials that are being brought forward to support those trends. So we're seeing some good advancement in the material usage and the capabilities in building envelope performance in new buildings. And then finally, air tightness and these new efficiencies, they are continuing to be adopted in the federal workplace. The Department of Defense, in their uniform facilities guide specifications, they now have an air tightness testing protocol, which was issued May of last year, and I would encourage you to take a look at that. Next slide, please, Whitney. So what are we looking at in terms of air barrier, and what are we looking at in terms of envelope? Well, we see here represented that we have all 4 of our barriers in place in a very simple wall. We've worked on systems like this, and they generally take place in a 1-story environment, a child development center, a senior activity center, things of that nature. The number 61 that you see here, that is the fluid applied air barrier, and that represents your air barrier and your moisture vapor barrier. Number 41 is a rigid foam insulation that represents your thermal. And finally, on the exterior of the envelope, you have your brick, which is your primary bulk water barrier. Next slide, please, Whitney. So in this more complicated design, you can see that there's a lot more moving parts here. There's a lot more that's going into this particular design. It's a bulkier envelope. However, they still know that these 4 barriers are needed. Again, fluid applied air barrier being used as your air and moisture vapor barrier, your rigid insulation for thermal, and your brick on your exterior. Next slide, please, Whitney. So let's take a moment to talk about continuous insulation. What is it and why is it in place? Continuous insulation is just as it sounds, it's continuous, but the main feature of it is that it's there to separate your insulation plane from any structural members of the building. Why? Because structural members of any given envelope can become a thermal transfer. So you see on your left, that almost looks like a small house or a house design where you have your wood framing, your cavity insulation. Your foam board insulation is then run continuously on the outside of those framing members, then your exterior cladding. In the middle example, it's more or less like a small commercial building. Now you have steel studs, once again, cavity insulation, but there is your continuous insulation, again, in the form of foam board, and then your brick sits outside of that. The graphic on the right represents a bit of a different approach, but the same principle. You've got your cinder block, which acts as your structure for the wall. You've got continuous insulation in the foam of foam board. Then your structural elements holding your exterior sheathing and cladding sit outside the continuous insulation. In each of these examples, you can see that the primary focus is to separate your continuous insulation from your framing members to retard that thermal transfer. Next slide, please, Whitney. So, how does this look in the field? A couple of examples for you. This is a vapor permeable foam board, and it's being applied to the most exterior portion of a new building. Please take note how the seams are taped to further try to inhibit or retard any air transfer. And then the exterior cladding will be installed on the outside of this. Next slide, please, Whitney. So, fluid applied air barrier over sheathing. A couple of points about this. Number one, in an attempt to develop materials to meet the market need, Georgia Pacific created this exterior sheathing with an air barrier material bonded on the outside of it. So you see fluid applied air barrier on the cinder block below the window cutouts and the sheathing above. What I'd also like you to take a look at is not only are the seams hit with sealant, but each individual fastener hole either has a dab or a thumb smudge of sealant on it, again, to try to stop any of that air movement. Next slide, please, Whitney. So, we also see closed cell spray polyurethane foam being used more heavily in all types of construction. Here's a couple of examples for you of large scale projects where the structure is built, the foam is then applied to the outside, and then your exterior cladding goes on. Why is this gaining in popularity and why is it attractive? Because if you use closed cell polyurethane foam, you are achieving all four barriers with one material application. That's one crew, once around the building, one material, and you have all four barriers. So it's saving people a lot of steps. It's saving supervision from a lot of different crews trying to work on that envelope. And it's quite frankly faster and better. Next slide, please, Whitney. So in the new construction environment, we're looking at the building envelope. Yes, there's an increased focus. The trend is toward continuous insulation or CI. And there are more and better building materials being manufactured specifically for the building envelope. After the slides, if you received the slide deck today, beyond the Q&A slide, there's an appendices and there's some design guide links in there that I would encourage you to take a look at. Next slide, please, Whitney. So let's move on to existing buildings. So the building envelope is a critical element of a resilient building. Yes, it's often overlooked when prioritizing energy and capital funding. And I'd ask you to pay particular attention to number 3. Over time, building envelope materials expand and contract. And it's important because it's not just over time, it's all the time. Just as weather changes almost hourly, when any building or materials that make up a building go through a series of freeze thaw or wet dry or hot and cold cycles, it absolutely impacts the condition and the durability of those materials. And understanding the building envelope materials essentially are put into place, building envelope materials are put into place to try to wrap two dissimilar building materials. It only exacerbates the problem. Why? Because two dissimilar building materials will expand and contract at different rates. They'll heat up and cool down at different rates. So the material that's there to bridge that gap is under constant stress. So gaps do indeed form because of that constant stress and because of that degradation. Gaps do indeed form, and that greatly impacts your energy efficiency. So how do we approach it? We go through building envelope assessments, and that allows us to locate and uncover those gaps in the break and to try to reassure your building envelope's continuity. Next slide, please, Whitney. So yes, this graphic looks familiar because we take the same approach. Different building, same ideas. We do begin looking at the roof because that's the top of the envelope. What in an existing building assessment and audit, what you're hoping that your company performing those audits do is they follow this methodology, right? They start at the roof wall intersection because it's traditionally problematic. They take a look at your walls, what type of condition they're in. What about your doors? Doors get an awful lot of use and they get beat up over time. Are they still holding their seal? Are they still in good workable condition? Are they helping us maintain our energy? What about your fenestrations or your large planned holes? What type of shape is the fenestration in? Can it be sealed or repaired? Or do you have to empty out the fenestration and replace whatever was in there with perhaps more efficiency window sets or a high efficiency window wall? Do we have the ability to perhaps put on energy savings performance panels to bolster that thermal? Taking a look at your planned holes in your envelope, exhaust fan, ducts, vents, because they have active machinery inside of them many times, or they're held together with building envelope sealant materials, they also expand and contract and can degrade over time. And then let's look at the windows. Are they high efficiency? Are they low efficiency? We work in several school environments where you run into literally 1972 aluminum single pane clear glass windows. Terrible for efficiency, terrible for noise, and it's just easier and simpler in most cases to remove them and put in new high efficiency windows. And finally, if your building does have a crawl space, is it properly insulated and is it properly air sealed? Next slide, please, Whitney. So how do we do this, or how does the industry approach it? Well, the industry approaches it through assessments. So when you undertake an assessment, yes, you're there to find and repair problems, and you're going to get a good energy savings from that, and you're going to get a good financial impact. But there are other rewards involved when you undertake a step like this. First of all, you're reducing your heating and cooling operating costs, so that's both financial and help on your equipment, and it's helping you meet your federal requirements. You're reducing your building's environmental impact, which is a climate reward. You're increasing occupant comfort, which has a directly proportional relationship to an improvement in productivity. And you're prolonging the life of the building, which is going to be a future budget reward. Now, if you take a look at the bottom, I included this quote because you're going to see how this impacts later on, but retrofits, and this is from the Department of Energy, then their Energy Efficiency and Renewable Energy Office. Retrofits of existing buildings are particularly crucial to envelope energy savings because nearly 93% of residential and 60% of commercial buildings that exist today will still exist approximately 25 years from now in 2050. Building envelope performance is also critical for occupant comfort, productivity, and health. And we'll take a look at a different iteration of that metric just a little bit further down. Excuse me. Next slide, please, Whitney. So your assessment report, when you have it done, it should identify for you where those leaks are, lots of holes in the envelope. It should then sum them up for you into one big hole, which is expressed as an ELA, or an estimated leakage area. It should estimate the savings, both dollars and environmental impact, gained by shoring up that hole and shoring up your envelope. And it should estimate the return on investment for the work that's identified in audit. And importantly, that return on investment should be based on the actual energy cost of the building being assessed. There's no sense in trying to do modeling when you have actual energy bills at your availability. That makes your ROA that much more precise. Next slide, please, Whitney. So what are the assessment tools? The assessment tools are which is a smoke pencil, which is simple yet absolutely invaluable tool for going through assessments, an IR camera, and an IR camera many times will allow us to see temperature deltas going on that the naked eye can't see, and we have examples of that later, and a trained assessor. And what we'd like you to take note of is the fact that a trained assessor has to get up close and personal with the building they're assessing, as you can see in this photo. While there are certainly patterns that emerge in certain buildings, particularly those of similar design or vintage, it really does take a physical inspection to gain the knowledge of the condition of the building envelope. So it's important that you've got a hands-on assessor that's taking care of this for you. Next slide, please, Whitney. But there are also more advanced diagnostic tools, and these are based on pressurizing a building, whether it's negatively or positively, and they measure the air leakage once the building is pressurized. and that's typically used as a blower door, known as a blower door test. The middle graphic you see, the one with the one fan at the bottom, that's usually residential. The multi-fan setup on the upper right with 2-3 fans, that's again a small commercial space. And then finally, if you want to pressurize a large building or any type of CI&I building that's large, you can see down below 2 truck-mounted, really large fans that will enable you to accomplish that. Now, keep in mind that a lot of the new federal requirements coming out are looking for those type of precise specifics on your air leakage rates that you can gain by this testing. And B, in those in the very large fans, sometimes they can't be used in a healthcare environment because they're afraid of cross-contamination and pushing too much potential for infection around inside that space. So next slide, please, Whitney. So when you have your assessment done and you determine what your leakage rates are, what do we then embark upon? Well, we embark upon straightforward solutions that have big impacts. Window caulking, weather stripping, sealants around windows and doors, foam board and polyurethane foam. Those are just some of the materials that are used to plug those gaps. Next slide, please, Whitney. But before we move on, I want to harken back to the existing building metric we mentioned earlier, and I want to try to give you some aspect of the size of the existing building market. If you look in the upper left, air sealing requirements, they essentially appeared on the scene in 2007 with ASHRAE 90.1, and then the IECC followed in 2009. In the upper right, you see that air barrier requirements, they first appeared again through ASHRAE 189.1 and 90.1 in 2009 and 10 respectively, the IECC in 2012. Now, if you look at the graph in the lower left, you see that 95% of the commercial buildings that are in use today were built before any of these requirements were on the scene. So that means that the existing building market is both enormous and truly in need of some of the services and shoring up your building envelope that are out there today. Next slide, please, Whitney. So, building envelope assessments, I wanted to give you a couple of photos to show you what you might be dealing with. If you take a look at our trusty air pencil right there, you take a look at our smoke pencil, you see the amount of draw that's going through those building elements and those envelopes at the roof wall intersection. And it's often overlooked, and you can see our friend, the corrugated metal paneling, working around I-beams and joist. Next slide, please, Whitney. Here's an additional photo using the smoke pencil at the top of a roof wall intersection. And you can see there the smoke being drawn out. But what I would like you to keep in mind is that that draft and that air exfiltration is taking place 24 hours a day, 7 days a week, 365 days a year until that is corrected and sealed. Next slide, please, Whitney. So I'd like to go through the next 2-3 slides to demonstrate for you what thermography can show us that we can't see with the naked eye. Here you see our typical metal pan roof. You see the top of the vertical wall there with a little bit of air scarring on it. But when we put a thermal camera up to it, Whitney, next slide, please. This is the type of heat that's coming into that building through those open gaps. So being here in Charleston, and it's almost July 1st, we are now in the season of what they call the 90 and 90s, right? 90 degree temperatures, 90% humidity. When you have hot, moist air with an influx like that, that is going to hit your cold ductwork. It's going to condensate, drip, create mold. So it's really important that we try to identify precisely where all this hot, moist air is coming in. Next slide, please, Whitney. Here we see a gymnasium. This is a school in Alabama, and that looks to be a really nice ceiling. It looks to be in good shape. It's clean. The structural elements are in good shape. But then when we put a thermography camera on it, next slide, please, Whitney. That's what we see. that is a tremendous amount of heat gain being rifled down into that building through not only the roof structure itself, but also the gap in the roof wall. Next slide, please, Whitney. So we're taking a look at a door set. If you're walking by this door set, you think, yep, they're in pretty good condition. That mullion in the middle looks to be very good. Everything seems to be in order here. But if you switch to the next slide, you take a look at what we found through thermography, you'll see that the weather stripping or the weather seal is not doing its job. It's not being effective, and there's a tremendous amount of heat coming through those areas. Next slide, please, Whitney. And the last example for you is, here we have that same gymnasium that we looked at before. This is an old unused exhaust fan that's just sitting in the vertical wall. I'm sure people have just left it there. But if you take a look at it through thermography, Whitney, if you want to take the next slide, you'll see the amount of heat that's coming into that space that you're now paying again to cool through that open exhaust fan that, quite frankly, nobody is paying attention to. So, next slide, please, Whitney. When we look at existing buildings, we're looking specifically at all functions of the envelope, but also those breaks in the envelope where the real degradation and occurs, allowing more air leakage. So here we see a door with a challenged piece of felt there. Next one, please, Whitney. The name escapes me at the moment. Here we see a window set that's gone through so many freeze-thaw cycles, so much air infiltration. Really and truly, it's degraded to the point where it's virtually useless. Next slide, please, Whitney. Here we're looking at a window set where we see an open gap in the window. And if you take a look on the inside of that window down to the bottom left, you see that it's actually rusting from the inside because of all the moisture that's being pulled in. And on the lower right, you can see that they actually screwed the window shut so that nobody could open it. Next slide, please, Whitney. Here we see the same window set, so much air infiltration that there's dirt, dust, pests. And yes, poignantly, these pictures were taken less than a month ago at a healthcare facility. Next slide, please, Whitney. So what does it mean when we have what does it mean when we have moisture intrusion? Whitney, if you can just advance just 3 more, I believe you're going to have some graphics pop up on here. So this is a simulated test that took place in Ottawa, Canada, and obviously it's in metric form. So 1 square meter is approximately 10.5 square feet. On your left, you see a panel with a fluid applied air barrier on it. Over the course of a winter in Ottawa, Canada, 1/3 or 10 ounces, 1/3 of a liter or 10 ounces of water, moisture, diffused through that material. On the right, they took the very same board that's identical. They cut a 3/4 inch square hole in it. And over the same time period and climatic conditions, nearly 8 gallons went through that 1 3/4 inch square hole. So not only is that a dramatic illustration of just how much water can enter into your envelope, the stark reality of it is that water eats building materials. That's what it does. Whether it's an abrupt flood, which is a catastrophe, or it takes time and it's seeping in your envelope over time, water eats building materials. And when you have holes in your envelope, this can be some of the result. Next slide, please, Whitney. So what are the recommendations when you do an assessment and now you're trying to approach your building envelope in your existing building? Number 1, air sealing. It's inexpensive. It's a building maintenance issue that unfortunately many times goes ignored, but it's truly worth the investment. After air sealing, you insulate. Do we have an opportunity? Do we have the space, and do we have the budget to bolster the thermal condition of our wall? And then, and only then, do you go back and look at your HVAC? Do we have the opportunity to upgrade? Do we have the opportunity to redesign our system? Because now we can even perhaps downsize our system, because what we're paying to heat and cool is staying in the area where we want it to stay, and we don't have a constant air exchange that our HVAC system is battling. So yes, and importantly, when you have this type of work done, the return on investment begins at installation. When you start shoring up holes, you stop that air exfiltration immediately, which means that at the same time, you're immediately starting to bring down the level of work that your HVAC system has to do to keep that indoor environment comfortable. Next slide, please, Whitney. So field observations and issues compiled in report metrics. So Whitney, I'm going to ask you to go through the next few slides just with 1 or 2 second intervals, and you'll see what I mean. So if you take this window set, right, and then you take that window, which you saw a picture of, and this one, you multiply all those by this, and then you multiply that by this complex. That should deliver for you the metrics right here. So where were those photos taken? It was at the VA hospital complex in Pittsburgh approximately a month ago. What are we suggesting, or what do we realize? What we realize is that the size of the hole in the building is 430 square feet, which is sizable to say the least. That if you make an investment of $242,000 and change, you are going to garner an annual savings of nearly $36,000. So your payback is 6.7 years. In terms of actual heating and cooling, what are we saving and what type of efficiencies and impact do we have on our system? Well, we can see that our annual heating savings in MMBTUs is 2168 over the course of that year. Our cooling savings are 285. There's our total MMBTU savings, which add up to our total CFM savings. What's CFM? CFM is the total amount of cubic feet of conditioned air that's saved by revitalizing the building envelope. In other words, instead of constantly having to run your system to adjust for the air infiltration, exfiltration, by shoring up your envelope, you've now stopped almost 332,000 cubic feet of air exchange. Next slide, please, Whitney. And you can also ask, and people should be able to provide for you, hey, what about if I just do the window sets? And now so they can provide for you that metric as or per ECM, or energy conservation measure. Here we see that from the pictures we saw, there's 37,333 linear feet of window perimeter seal. It will cost you over $193,000 to do it, but your realized savings will be approximately $33,000 a year. So your payback just for that ECM is 5.9 years. Next slide, please, Whitney. And also, you can have a report with more or less a dashboard on it. Please show me everything that you found. Please show me everything that you intend to do. And then in the lower graphic, okay, what am I actually saving in my energy? How does that translate into dollars? What's it really going to cost me to do this, and what's my payback period? Again, it's more or less just a reconnoitering of the same metrics, but this is what you could and should expect to see if you have an investment grade audit done on any of your buildings. Next slide, please, Whitney. So let's take a look at a couple of examples of ECMs in situ. Next slide, please, Whitney. Here we have building envelope repair. This is the top of a wall. And you can see the open air leakage that was around the entire exterior of this building. And with some simple spray polyurethane foam, it's sealed. And that foam will not go anywhere. It won't degrade. It won't move for the entire length of that building. Next one, please, Whitney. Here we see an example again of an attic crawl space with a wooden floor, the top of the structural wall with all the structural elements going through it, bar joists and things of that nature. What did that create? It created an 8-inch gap around the entire exterior wall of this building. Foam board and spray polyurethane foam. It's very straightforward, but it's extremely effective, and now you stop that air exchange. Next slide, please, Whitney. Here's our old friend, the corrugated ceiling deck. Once again, roof wall intersection not sealed, foam board, polyurethane foam, sealed. So let's move on to our featured building materials. Next slide, please, Whitney. Spray polyurethane foam. It's been brought up, obviously, on a couple of occasions today. It is widely used in both new construction and retrofit. It is the highest R value per inch available in the closed cell spray foam form. In closed cell spray foam, it provides up to 400% additional racking strength to any materials to which it's applied. So it gives you a little bit more durability. And again, closed cell spray foam is recognized by FEMA as a Class 5 flood damage resistant building material. Next slide, please, Whitney. Here are some examples of spray foam being used in situ. Notice the upper left, which is roofing. Next slide, please, Whitney. I wanted to specifically highlight the ability of spray foam roofing because not only is it a seamless, monolithic, and durable system, many systems offer an unlimited wind uplift warranty. That's how ardent it is, and that's how strong the bond is. But most importantly, many times when you install this type of system, you will not have to tear off your existing roof. And by doing that, you're essentially cutting your cost to re-roof in half. Next slide, please, Whitney. So I felt it would be remiss, particularly given today's audience with the Society of American Military Engineers, not to highlight one of the most outstanding uses of closed cell spray foam. Here we see that on over 900 non-permanent forward operating base structures, otherwise canvas tents, over 900 of them were sprayed in the Middle East during wartime. What were the results? It used to be 200 fuel trucks a day that brought fuel back and forth to generators running 8 AC units. And once these tents were insulated with closed cell spray foam, that dropped to 40 trucks a day. That's an 80% reduction in trucks, 80% reduction in crews being exposed to IEDs, 80% of, quite frankly, the ability to save lives. What happened afterward in terms of the cooling? 8 AC units were working hard to maintain 92 degrees. After the foaming, 2 AC units were maintaining 75 degrees. The payback, 75 days. The annual fuel cost savings of what cool $1 billion. Next slide, please, Whitney. Let's move on to fluid applied air barriers. Yes, they're primarily used in new construction because you basically get one shot at that new wall. It is the fastest growing building material in the air barrier and building envelope market. And they come in two forms: vapor permeable, which is a moisture vapor retarder, and vapor impermeable, which is a moisture vapor barrier. The only caution I would give on vapor impermeable is that sometimes that creates and becomes a condensation plane. Next slide, please, Whitney. Just a couple of in situ shots to see the flexibility. Fluid applied can be either sprayed or rolled. Next slide, please, Whitney. It's primarily used in the commercial, institutional, and industrial. Next slide. And not only is it a fast application, but it is seamless. It's a seamless barrier, and it can conform to various wall types. So next slide, please, Whitney. So I want to, again, thank you for your time. I know that was a relatively short walk through the building envelope world. I hope you garnered some information, but this is who we are. Our CEO, Casey Baker, again, a Coast Guard Academy grad, as Whitney mentioned, and a captain in the Coast Guard after 27 years, and just a tremendous asset to our organization. And in the lower left is Kurt Riesenberg. Kurt is our business development contact in our DC office. And thank you, Kurt, for your help with the slides. Next slide, please, Whitney. And Q&A. So Whitney, I'll turn it back over to you, my friend.
Great. Well, Bob, that was amazing. So I definitely really appreciate that in depth. And I know we definitely have a lot of questions coming in. So I will, sure. If you have any questions for Bob, please feel free to use the chat, and we'll dive right into it. So Bob, as it pertains to new construction materials, do you know of any newer materials that have come to the market recently that may prove to be beneficial?
Yes, as a matter of fact, in the fluid applied realm, one of the drawbacks of fluid applied is the present day materials, or up until about 4 or 5 months ago, when they were applied, if you got hit by a rainstorm within the next probably 2 to 3 hours, a lot of that had the ability to wash off. Henry, who is now owned by Carlisle, they came out with a product about 4 or 5 months ago that 30 minutes after application, it's waterproof and it's there. So it's only adding to the speed and flexibility of fluid applied air barrier material.
Got it. Okay. We have a question coming in from Brad Coleman. Brad asks, how is exterior cladding connected to the exterior closed cell foam?
Basically, what happens, Brad, is the cinder blocks are put up, and then you put in your brick ties, and then the spray foam is sprayed right over the brick ties, and then the bricks are applied to the ties approximately with a 1-inch air gap outside of that closed cell spray foam. The typical spec that we see is a 2-inch application on the outside of cinder block, but we only do that after the brick ties are affixed to the cinder block.
We have a question in from Caroline Wang. Caroline asks, what are the fire protection consideration for envelope products?
There are two considerations. First of all, if you wanted to take an additional step, you can seal it with foam and then put mineral wool on top of it, which is a fireproofing material. Or they do make such a thing, it's called fire foam. And fire foam is created for both fire stop and those 1-hour firewall areas. And fire foam, the foam you saw in the presentation today was white in color. Fire foam is typically orange in color to match the orange fire caulk that you typically see on a wall.
Great. All right, James, the slides will come out right after today's presentation. So Sunil asked, what kind of glass cladding building?
Well, glass, when glass is a cladding, it's actually acting as a curtain wall, and a curtain wall is nothing more than the structure is top and bottom, and it more or less is put in place by itself. But there's a myriad of options. I'm not a window expert. I can tell you that right now. However, I do know that when your glass is your exterior cladding, it's in the form of a curtain wall, and there are several options. Usually aluminum, right? Usually it's a sturdy aluminum with, again, dual pane, low E argon. An exterior cladding typically has a 1-inch interim in between the 2 panes of glass to create the dual pane, not 3/4 inch, although 3/4 inch is common as well.
Great. We have one from Bradley. And by the way, we can stay. Bob can stay for a few minutes afterwards if we have additional questions.
Yeah, Tom Savoda had one that I saw come up about auxiliary air. Once you see the building, I'd like to answer as well. But go ahead, Whitney, please.
Yeah, sure. We'll have one more, and I have a few SAME slides to go over. But Bradley asked where the individual desert tents were requiring a separate AC unit before treatment, but 2 units afterwards. Question: were the 2 units joined by a duct system to the extra tents?
No, in that particular instance, that was the dining hall. That's why there was 8 fans that were trying to feed a massive dining hall. And after that entire dining hall complex was insulated with closed cell spray foam, it was 2 fans with 2 direct ducts into the area.
Absolutely. So we have Bob will be more than happy to stay on if everyone has. There's a bunch of other questions. I do have a few slides I need to go over for SAME, then we can go back to questions because there are a lot of additional questions that have come up, which is great. We'll get right back to those in a second. So, but thank you, Bob, for this. It's been incredibly educational. And thank you, everyone, for participating in the chat today. We will address the questions in a moment, but I did want to wrap up our first Friday. Our next first Friday will be, and be respectful of everyone's time. Next first Friday is August 2nd on Trust But Verify, a side channel monitoring for supply chain resiliency from our presenters at the University of Florida Institute for National Security. Registration is open now. So if you are interested in knowledge of current educational topics for First Friday for our members, we are now accepting presentation applications for the fall. So please be sure to visit our website today, and sponsorships are available for our popular program. So please make sure you mark your calendar for upcoming DC Post opportunities on Thursday, July 25th at the Army Navy Club for our next in-person luncheon on climate resiliency and electrical infrastructure, featuring for our industry government engagement. We'll have speakers from the Department of Energy, DC Department of Energy, and the GSA. So please hurry up and register, because this program will sell out quickly. And join us on Sunday, September 15th for our annual Team River Runner Family Day, as we enjoy the Potomac with kayaking, boating, and a potluck picnic cookouts. This is sponsored by AFG and hosted by the SAME for the DC Post, Mid-Maryland, and DBIA Mid-Atlantic. This event is free, and the whole family is invited to join in on the fun. So please register today. And would you like to reach out to a community of 7,000 architect, engineering, construction, technology leaders? With our annual Post sponsorship, you have the opportunity to leverage our network to showcase your firm with visibility and international recognition you won't get anywhere else. So please consider an annual sponsorship or a program sponsorship, including the First Friday series. And then join the national SME community with the largest conference of the year, which is the Small Business Conference, which will be November 20 through 22 in New Orleans. So we look forward to seeing you all there. And registration is open, and early bird rates are good through August 30th. And hotel will open up in July. So thank you all again for joining our summer First Friday series with Bob Duke. Look, Bob's going to stay on for a couple of additional minutes to answer some questions. Please be sure to look out for document delivery for the slides, your PDH certificate, and the participants today. And have a great weekend and a happy 4th. So thanks again.
Thank you, folks. Thank you.
Yep.
Thank you, Whitney.
So Caroline asks, is the fire foam one-faced or dual-faced, or is it depending on where they're used?
It's one faced. So it's a singular material. It's still an A and B coming together, right? Foam is not to get too technical, but it's methyl diisocyanate and polyol surfactants resins. And the B side, it's truly closed cell foam in a can. When you apply it, the chemistry grabs some of the moisture in the air to kick off the reaction, but it is a singular product.
Okay, and then Tom asks, if you're sealing up a building this tight, do you have to look at supplemental ventilation air for older facilities?
I would suggest so, yes. So Tom, an approach to that, anything from residential all the way up to large commercial, is to simply approach it from the air intake side. So what we suggest is that if you're finding that your building is running pretty ardently negative, because when your system calls and it's pulling in from internal and it's running negative, you can put a pipe out. You take a pipe for makeup air, okay? You stub it into the back of your air handlers so that when the system calls, it pulls that air in from the outside to your back of your air handler. It gets filtered, cooled, dried, and then is redistributed through your ductwork. So now you're making that building run slightly positive, if that makes sense. So it's a good question. And yes, if your building is running pretty ardently in a negative way, when you open up that door, you hear the whoosh. And as a quick sidebar, 85% of all buildings typically run negative. Yes, put a pipe out for makeup air, stub it into the back of your air handler, and that can turn that situation around.
Excellent. That was it. Okay. Well, that was, if anybody else has any questions, then again, please feel free to save the chat. Just go to save and click save chat. And other than that, thank you, everyone. This was much appreciative. Have a great weekend, and we'll see you all at the next SAME DC event.
Whitney, thank you, and thank you everyone attending today. Very much appreciated. Thank you, Whitney.
All right, thank you.
See you guys.